Chapter 4, Lesson 4 of Precalculus. We're continuing our look at the graphs of the sine and cosine function. And what we want to do in this lesson is take what we looked at last lesson, and we kind of began talking about what the sine graph is and what the cosine graph is. We'll look at the sine first, and then we'll quickly apply the same principles to the cosine because they're very similar. The sine, you remember, is a tracking of the y values on the terminal side of an angle as it rotates around on its vertex, and it rotates in a 360 degree or a 2 pi circle. And the sine function tracks what the y value does. Here at 0, the y value is 0. It then begins to climb as it raises higher and higher. It gets to a high point of 1, at which point the y value then starts to fall, as if you're going down a roller coaster. You hit ground level, you're at 0, the roller coaster goes underground, so now you're going down, going down, going down until you finally reach the bottom. And then it turns around and starts to rise back up as the y values begin to go back up. So it completes this cycle. And we talked about what the cycle is. It starts at 0, it reaches its max at the pi over 2 or 90 degree angle. It reaches back down to 0 at pi or 180. It reaches its minimum at 3 pi over 2 or 270, and then back to 0 at 2 pi. Okay, so we're going to use this pattern here to help us graph the sine function. Okay, so we want to remember 0 max, 0 min, 0, and it takes place at these very important points. Alright, so let's take a look at a graph piece of paper here, and we're going to use this. Now this one's already labeled for us. Later on I'm going to white those out so you can see, because when we start doing stretches and shrinks, you'll see that the picture of the wave doesn't change at all. The only thing that changes is where these points occur. So we're looking at the equation. Let me make sure I got this out. We're looking at the equation y equals sine of theta, where theta is these angle measurements that are put in for theta, and then what comes out are the y values of that coordinate. Now, you remember the pattern is 0, max, 0, min, 0. Okay, so at 0, the y value of the sine is 0. So we have a point here. The maximum is at pi over 2. So at pi over 2 here, it reaches its maximum value. Now, the maximum value on the unit circle is 1. So we're going to make this 1, and so this would be 2. So it reaches its maximum value. When it's at pi over 2, it reaches its highest point. It gets back to 0 when it's at pi, so we'll put a 0. It reaches its minimum at 3 pi over 2, so at 3 pi over 2 it reaches down its minimum. And then at 2 pi it gets back to 0. So we go from 0 to its max, to its 0, to its minimum, then back to 0. And then we just simply connect this with a nice smooth curve that goes through, and we have our sine wave. Now, again, if we rotate it in a negative direction, we do the same thing, only in reverse order. It goes down to its minimum, and then back to 0, up to its maximum, and down 0. Or if I go out here to 2 pi, where it begins, negative 2 pi. 0, maximum, back to 0, minimum, back to 0. And so this rotates. So this repeats as it goes through, as this terminal side continues to rotate around that circle. So this is the equation for the sine function. This is what it looks like, and these are the points that we'll want to remember. Okay, so on each graph I'm going to require that these values are put on the graph, because when we stretch or shrink this, these values are going to change, but the graph is going to look identical. The only thing that's going to happen is it's going to be squished together, or it's going to be stretched out, or it's going to be stretched vertically or shrunk vertically, whatever. These values are what changes, but the shape is generally the same. It goes all up and down like this. Okay. Now, that's the sine function. So let's take a look at the cosine and what it looks like. The cosine function you remember, so we have y equals cosine. Its pattern is different. It starts out, whoops, 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 keep saying whoops. It starts out at its maximum. So at 0, it's at its maximum, and it reaches a maximum of 1. So here, we start out here, the sine function starts here. Okay, then it goes down to 0 at pi over 2. At 90-degree angle, it's at 0. And then at pi, it reaches, whoops, I got that backwards. At pi, it reaches its minimum value at the angle pi. So it reaches down to -1. Then it gets back to 0 at 3 pi over 2. So it's back to 0. And then at 2 pi, it reaches it's back to its, I don't know why I keep doing that. It reaches its maximum again back at 2 pi. So again, we start at max, 0, min, 0, max. That's the pattern, and again, it's a nice little, that's not too bad. I can do better though. All right, and then again, it repeats this way. Now I'm going to go out here to 2 pi, negative 2 pi, and that's going to be, it's going to be at its max, 0, min, 0, and then max, and so it repeats just like the sine function does. Okay, and so this is what the cosine function looks like. Now, I want you to understand something. Why do we call these sinusoids? Because actually, if you think about it, or if you look at it, let me take this away from here to here. Okay, and if I take this away from here to here, what does that look like? What? 0, max, 0, min, 0. Well, that's just the sine wave. And the only difference is that this 0 point has been shifted to the left, negative pi over 2, or it's been shifted to the left, pi over 2. So really the cosine, I accidentally erased that. The cosine function is really simply the sine function shifted to the left, pi over 2. And that's why they're both called sinusoids, because the cosine is simply the sine function shifted to the left. I want to take a few minutes at the end of this video to talk about a vertical stretch or shrink of these sinusoid functions. Now, what we've learned over the past couple of years about our functions and how we vertically and stretch them and shrink them and where these values show up in the equation are all the same for the sinusoids. We are, however, going to use different vocabulary because these functions are a little bit different in that they're periodic. They repeat the same pattern, unlike the other functions which grow, increase, or decrease, but they don't repeat. Some of the vocabulary is just a little bit different, but it means the same thing. And where these values show up in the equation doesn't change, however. So as a review, if we have something, a function like x squared, the vertical stretch or shrink, remember, shows up in front. If we put a negative sign in front, that's a reflection over x-axis. If we put a negative sign in front of the x, that's a reflection over y. Okay? If we add something to the x value, then that is a shift right or left. If I substitute in a value like 2x, that's a horizontal stretch or shrink. If I add something to the outside, that's a movement up or down. All of these things apply to sinusoids, nothing different. And they show up in the exact same places, so there's nothing different there. We just have some vocabulary that we need to learn that means the same thing. In other words, new words that mean the exact same thing. Okay? All right. So what we want to talk about in this last couple minutes here is the vertical stretch or shrink. Okay, so that vertical stretch or shrink, and remember that shows up in front of the function. So in sinusoids, or when we're talking about sinusoids, this vertical stretch or shrink, let me go ahead and write that up here, is called the amplitude of the wave or of the sinusoid, the amplitude. Okay, and it's represented by the letter A. So if I wanted to write this using an amplitude, I would put A here, sine of theta, and the A is the amplitude. Now you're in your book, it'll say the amplitude is the absolute value of A, because if we put a negative sign in front, that is not affecting the amplitude, remember that's a reflection, so that's separate. That's separate from the amplitude. The negative sign is the reflection. So A is the amplitude, and it goes right here. And as we've been talking about all year long, so my job then is to know what that letter represents and then know how to calculate it. So how do you calculate the amplitude? You calculate the amplitude by taking the maximum value of the function, and you may get that from a table, you may get that from a description in the word problem, you may get that from just looking at the graph. Whatever it takes, you'll need to find the max value of the data. You subtract the minimum value of the data. And again, that may be searching a table, it may be a description in the word problem, or it may be just looking at a graph and grabbing that minimum value out. You take the maximum value, subtract the minimum value, you divide it by 2, and that will give you your amplitude. Okay? So the vertical stretch or shrink is the max value minus the min value divided by 2, and it is a vertical stretch or a shrink of the sine wave. And again, it doesn't matter if it's sine or cosine, they're both the same because they're both sinusoids, they both have the same shape. So we would calculate that in the same manner. Okay? I think that's fairly straightforward, so I'm not going to do an example. Once we've talked about all of the different transformations of the function, then I will do a video where I do a number of examples showing you how to calculate it maybe, or how to graph it at least by looking at the equation and then working with it from there.